Hi, good evening everyone. Today, let's try to learn about some resistance reduction techniques or network reduction techniques, which is called as Thevenin's theorem. Actually, the purpose of these theorems is if you want to find out the current across any branch. So I want to find out the current across this branch. I can, for example, this is of some 5 ohms. I want to find out the current across 5 ohm. I can use nodal analysis or I can use mesh analysis to find this method. Rather than using this rigorous method, which is time consuming, and we need to solve around, it may have a equation, may have 3 nodal analysis, may have 3 unknowns. We need to solve all these 3 unknowns to find the v1, v2, v3, and to find i1, i2, i3. So all this complexity can be reduced by the analysis of the next network reduction methods called as Thevenin's theorem, and this theorem is developed by Thevenin. That's why this theorem is called Thevenin's theorem. Let's try to understand how to apply an Thevenin's theorem and what is the procedure behind it. Okay, so you need two terminal. So let us take an resistor. So Thevenin's theorem can be applied. So this is for a two terminal network, any two terminal bilateral. So it is allowing the current in this direction as some I, and the current in this direction I'm going to take it as a minus I. So this is a resistive network, any two terminal. So any two terminal bilateral. So bilateral means current in forward direction and current in backward direction, called bidirectional linear DC or AC network. This is an, so linear means which includes R, L, C. It may be DC network, AC network, can be represented by an equivalent circuit consisting of an voltage source and an series resistor. Okay, now so if you want to find the current across this 5 ohm resistor, I can find out the current across this 5 ohm resistor by using Thevenin's theorem. So the purpose of this Thevenin's theorem is a complex network which may have more than 5 nodal equations, which is very tough to do by calculator. We can solve in a simplest method, or we can find the current across and any branch by using Thevenin's theorem. So the equivalent circuit of Thevenin's theorem is like this. The equivalent circuit of Thevenin's theorem. So the equivalent circuit of Thevenin's theorem is, so see the equivalent circuit of Thevenin's theorem. We are going to have an voltage source where this is called as a open circuit voltage source, and we are going to draw a resistor where this resistor is called Thevenin's resistance. This is the equivalent circuit, and you have to remove the load resistor and replace the load resistor like this, where this is called RL. So so this is the, for example, this is the load resistor given to us 5 ohm. We want to replace the complete network with this network and replace the same load resistor RL. So I can find out the current IL, where IL is called load current, where RL is called load resistance. The current IL can be, the voltage at this point is VOC. So therefore I can write down IL is equal to, current is flowing across R Thevenin and the current is flowing across RL like this. So IL can be written as so the leading polarity of the voltage VOC minus 0 divided by, so these two resistors are connected. I mean, what are the resistors connected in that branch? R Thevenin plus RL. So this is a standard formula to find out the current after drawing the equivalent circuit. So this is the equivalent circuit of Thevenin's theorem. So here it involves two steps. First one is finding out open circuit voltage. Second one involves finding out the internal resistance, and it is also called the Thevenin's resistance. So coming to the first step, so how to find out open circuit voltage? So we'll solve with problem, then you will be more confident. So how to find out open circuit voltage means, so load resistor will be given like this. So remove the load resistor. When you remove it, automatically this will become as open circuit and current will become as 0, and find out the voltage VOC. It's called remove the load resistor and find the voltage across that load resistor. That voltage is called open circuit voltage. Since the load we are removing, it is performing as open circuit, the voltage at that open circuit is called as open circuit voltage. This is the first step. Coming to the second step, so in solving this second step, we have two methods. So how to find out RThevenin? First one is if you have only dependent source. So this is the current dependent source, and this is an voltage source. When you have independent, sorry, these two are independent sources. One is voltage independent source and current independent source. So when you have independent sources, the formula is replace the independent sources with their equivalent circuit. For example, you have an independent source of 5 volts, so you deactivate this. So what is the concept of deactivation? So deactivating this means we want to make this voltage as 0. How we can make this voltage as 0? We try to short circuit. When you short circuit, so you are going to deactivate means you are going to perform short circuit. When we short circuit, what will happen? The current becomes maximum, and you have been short circuited. This current is called short circuit current, and this current is of maximum. And here when you deactivate it, automatically V is equal to I into R. So how much resistance is offered is whenever you short circuit, R is equal to 0. Okay, so I into R is 0, automatically V equal to 0, condition apply, R is equal to 0. So you have to remember these three cases in the case of short circuit. In a short circuit, you are going to have maximum current flows which offers an low resistance 0, and automatically the voltage is 0. This is how we are making a 5 volt source as 0 volt source. This is the concept of deactivating an voltage source. Now come to the concept of current source. Here you have a 5 ampere source, and what is this concept of deactivation? What is the concept of deactivation? So the concept of deactivation is nothing but I want to make this current source as 0 ampere. How I can make it 0 ampere is by performing open circuit. In an open circuit, the current becomes, in an open circuit current becomes 0, and the resistance offered by an open circuit is infinity, and the voltage becomes maximum. So you can understand here current I is equal to V by R. So here current has to become 0. When current will be 0? When resistance is infinity. So in an open circuit condition, current is 0, resistance is infinity, and voltage is maximum. Here you have at one end positive terminal as V maximum, and we have 0 volts here. So these are the two conditions to be fulfilled in open circuit and short circuit. In open circuit, current is 0, resistance is infinity, and voltage is maximum. In the case of short circuit, mm, resistance is 0, voltage is 0, and current is maximum. So that's how we are converting an voltage source deactivation means making the voltage as 0, and this is what the meaning of making a current source as 0. So this is the case what you have to perform while you are handling with the independent sources. Try to have the summary. When the given sources in the network are independent sources, so the voltage source has to be replaced with which is with its short circuit, and if you have a current source, it should be replaced with its internal resistance, where this is called as where we are going to have open circuit. So this current source you have to make it as 0. That is possible by performing open circuit. So that's how to deactivate a current source. That is how to deactivate an current source, where this is called first case. So coming to the second case. So this is about, we studied the first case. So the second case is about if we have independent source, if we have independent source and dependent source. So we'll discuss about this dependent source later. let's try to understand the case 2. When you have independent and dependent source, how to find out R internal is. So already in the first step we had find out VOC. So wherever the load resistor is given, okay, this is the RL given. So remove the load resistor and short circuit it. When you short circuit it, how much current will flow? Maximum current will flow, and find out that current, which is nothing but I short circuit. So first step we find out the open circuit voltage, and second step we have will find out short circuit current, which will give the internal resistance. That is how to find out the internal resistance when you have independent sources and when you have the dependent source. There are four types of dependent source. Based on the problem, we'll discuss this independent sources. Just coming to the third step, if in the given problem, if you have only dependent sources, if you have only dependent sources, so when you have only dependent sources like this, okay, this may be an voltage source or it may be an dependent current source like this. Okay. So when you are going to have a voltage source and we are going to have an current source like this. So this will be given as 5 into V2 something voltage dependent current source. This will be some 5 into I2. So current dependent voltage source. So like this, the sources if we have in the network only dependent are there. So then how to find out R internal is. So remove the load resistor. So load resistor is given. So this is the load resistor given. Remove the load resistor and you apply an voltage of VDC and find the current I DC. So you can see here when you find out this by removing the load resistance, you can find out R internal as VDC divided by IDC. Then automatically you can evaluate R internal. So this is a little bit simple to understand. There's nothing to confuse. So the finding open circuit voltage is very simple. So remove the load resistor. Whenever you remove the load resistor, it will act as an open circuit. Find that voltage. That voltage is called open circuit voltage. Coming to the second step, you want to find out internal resistance. The procedure for internal resistance, if you have an independent source, okay, voltage source is short circuited. We have to make this voltage as 0. That's why we are performing short circuit. If you have a current source, make it like an open circuit. This is about independent source. If you have independent and dependent source, what to do? So then you remove the load resistor and mark that short circuit it and mark the current as short circuit current and find that short circuit current. You divide open circuit voltage in the first step and short circuit current in second step. Then you can find out R internal. So coming to the dependent source, if you have only dependent, so these sort of sources are called as so I can call this as 5 into I2. This is called current dependent. What kind of source this is? Voltage source. Current dependent voltage source. So what kind of source this is? So 5 into V2, where V2 is called voltage. This is called voltage dependent. What kind of source this is? Current source. Like that we may have four types of sources based on the problem. Let's try to examine. So now let's try to solve one problem to understand our concept well. Let's try to write down the first problem. So the first problem is determine the current through 5 ohm resistor. Okay, so determine the current through 5 ohm resistor using Thevenin's theorem. Okay, so find current through 5 ohm using Thevenin resistance. The network given is like this: a current source of 2 ampere and a resistance of 1 ohm, and you have an 2 ohm resistor, and here we go, we have an 5 ohm resistor, and here you have an 5 volt source. Okay, so this is the load resistor given and is asking us to find out the current across this branch. Okay, let's try to apply Thevenin's theorem for this. Okay, so in order to apply the Thevenin's theorem, let's try to draw its equivalent circuit. Already I told the equivalent circuit, we are going to have an open circuit voltage, and we are going to find the first step is open circuit voltage, and second step is finding out Thevenin's resistance, and already load resistance is given in the problem. But the load resistance given in the problem 5 ohms. So RL is equal to 5 ohm. So this is one unknown, this is another unknown. You have to find out by using this Thevenin's theorem. And how to find out the load current? The load current across Thevenin or RL both are same. Therefore IL is equal to, the current is flowing from high potential to low potential like this. So how to write down IL? So current is leaving. What is the voltage at this point? VOC. Current is leaving. What is the leaving polarity? Plus. So plus VOC, and here minus 0 divided by, in this branch what are the resistors connected? R Thevenin plus RL. So this is the formula to find out load current for a given problem. So first step, let's try to evaluate is finding out VOC. Sir, how to find out open circuit voltage here? You see here, the procedure of open circuit is remove the load, resistor. Mean that removing the load resistor will become as open circuit and find the voltage. Okay, I am redrawing the network. I have an 2 ampere source. I have an 1 ohm resistor, and I have an 2 ohm resistor, and now this is open circuited. So here this voltage you need to find out, and this is the source we have, where this is an a 5 volt source. You can see here, so the voltage at this point is VOC, the voltage at this point is 0, the voltage at this point is 5 volts, and this voltage is 0 volts. I can say open circuit voltage is equal to how much? 5 volts. So this is step 1. Or if you are not satisfied with this answer, let's try to verify by method 2. Sir, what is this method 2? So you can see here, this is an practical current source. So I'm going to convert this current source into voltage source. So in order to overcome this confusion, I'm marking this as a node 1 and node 2. So between first node and second node, I'm having this parameter. I'm converting this practical current source into voltage source like this. Since current is going up, this will be positive terminal, negative terminal. V is equal to I into R. I is how much? 2, and what is the R value? Into 1. So this will be acting as a 2 volt source, and you are going to have a 2 ohm resistor, and here we have the source of 5 volts. Okay, so now we need to find this VOC at this point. You can see here how to find out this VOC. If you're not satisfied, so directly you have told this 5 volts, no, let's try to verify some other method. So you see here, I'm finding out the current in this branch. So the current in this branch is equal to, what is the voltage at this point? So 5, current is running plus 5, is going like this, and reaches here. This is how much? 5 minus 2 divided by 2 plus 1. So this is also 1 ohm, this is of 2 ohm. So this is nothing but 2 plus 1. This is nothing but 3 by 3, where this current shows a current of 1 ampere is flowing. So here what is the amount of current flowing? 1 ampere. Let's try to find out this 1 ampere current. So this is VOC, what you require. Current is flowing as 1, and how much amount of current is flowing? 1 ampere, which constitutes a drop of 2 volts. And you have one more resistor here. The current flowing is positive, negative, which constitutes 1 ohm. And again you have a voltage source here. This is of 2 volts, and you find out this VOC. Okay, now you see here, this is like this. This is positive terminal and negative terminal. So whenever the current is flowing, it creates a drop off. So apply Kirchhoff's voltage law. Already we directly can see here VOC, this is 5 volts. There's no need to directly say it. You may get doubt whether I want to verify by second method also, you can do it. So when you apply this here, current is leaving is plus VOC, and current is leaving here. What is the leaving polarity I have? Minus, what is the I value? 1 into 2, and current is entering at 1 and it is leaving here. So when the current is leaving, the current is 1 ampere. So current is leaving. What is the leaving terminal? Minus. So minus, what is the amount of current? 1 ampere multiplied with what is the resistor? 1 ohm, and current is once again leaving here. What is the leaving voltage? Minus 2 volts is equal to 0. So therefore VOC is equal to minus 3 minus 2, that is equal to 0. Therefore VOC is equal to 5 volts. You see here, this is by method 2. How much you got? The open circuit voltage is 5 volts. Without solving also I am saying that the voltage at this point, this both are same. The voltage here it is plus 5 and VOC is also directly plus 5. So any method you do it, the answer will remain as same. So you got VOC as 5 volts. Now second step is finding out R internal. So how to find out R internal is, so remove this load resistor, and you can see here this is an independent current source, this is an independent voltage source. Draw with its equivalent. Okay, so draw with its equivalent. So when you draw with the equivalent, that current source, the equivalent we are going to get like this. Okay, so you are going to get the current source, you are getting an open circuit, and here you are going to have 1 ohm resistor, and here you are going to have a 2 ohm resistor, and this is open circuit, and here you require the Thevenin's resistor, and here a voltage source is there. You are going to perform it as an short circuit. Here you are going to perform as an open circuit between 1 and 2. So I want the voltage. You see here, you want the find out RThevenin. The current will start flowing, and current doesn't flow in this branch. Why? Because the current always chooses to flow in. Okay, the current will start and current will not flow in this branch, and current will flow only in this branch. You can directly say that Thevenin's resistance is equal to 0 ohm. Current always flows in row resistor. So if you redraw it, this is called R Thevenin. If you want to do by, this is directly I am saying by method 1. You can solve it by method 2 also if you are interested. So the current will flow like this 2 ohm, and the current will come like this. The current will not flow in this branch. Why? Because the current in this branch is 0. Whenever the current in this branch is 0, the total current will come to 2 ohm and it will not get diverted and it will directly flow here. When they are flowing like this, I can say that these two branches are connected. Which connection? Series connection. When they are connected in series connection, therefore we are going to have a one resistor. You can see these two branches are connected in series. These two are in series. 2 plus 1 is 3 ohm, and here we are having one more branch which is offering R is equal to 0. So when you take the current will start. Current will not flow in this 3 ohm. Why? Because the current in this branch will become 0. Current always will flow in which resistive branch? Low resistive branch. Therefore R Thevenin's is equal to 0. Or if you want to do it of your without any work, so one is short circuited, one is 3 ohm, one is 0 ohm. So you require R Thevenin. The third procedure also you do it. This will have one resistor where the Thevenin's is equal to, these two are connected, current is entering. If these two are connected in parallel, product of resistors divided by sum of resistor, 0 plus 3, automatically how much? 0. That's what I am saying here. Thevenin's is 0, here also Thevenin's is also 0. If you use method 1, the current will flow only in short circuit path. Current doesn't take a chance to flow like this. If it flows also, the resultant will become as R equal to 0. So now by substituting in our formula, see the load current is equal to, so we are going to get VOC as 5 volts minus 0 divided by what is R. So this value we calculated as 5 volts, and R Thevenin we calculated this as some 0 ohms, and here we are going to have 5 ohms. So R Thevenin is 0 and load resistor is 5 ohm. So 5 will get cancelled and we are going to get the current as 1 ampere. This is how to find out the load current by using Thevenin. Let's try to recall the problem if you want to analyze. So this is the problem given to us. Find the current across 5 ohm resistor using Thevenin's theorem. So what I had done is the first step is we have to find out open circuit. I had removed the load resistor, and by removing itself these two are connected to the same point. I can say the direct voltage VOC, this is plus VOC and this is plus 5. I am saying that VOC is equal to 5. This one step. Or if you want to solve by using all your methods, find the current in this branch. I find the current in this branch is 1 ohm, and I try to apply the KVL. If you add all these drops, the resultant voltage from all these sources also will get 5 volts. Next one, second step is remove the load resistor. So I have been remove the load resistor and I have been redrawn it, and I can see here current will not flow in this branch, current will flow only in this branch. I am saying that direct RThevenin is 0. Or if you think that current is you can see these two branches are again in series. 2 plus 1 is 3 ohm, so current will start flowing. Current doesn't flow in this branch, current will flow only in this branch, again R equal to 0. So by substituting all the values of Thevenin's, 5 volts minus 0 by Thevenin's is 0 and RThevenin is 5 ohm, you are going to get 1 ohm. Hope this problem is able to understand this problem. Let's try to exercise the next problem.